Hi and Assalamualaikum. My name is Azhar Mohammad Shamsudin, metric number AN180046. I'm going to present my thesis report with the topic of synthesis of ZnO fluid for industrial dry wastewater via membrane photocatalytic reactor or MPR. My thesis is supervised by TS Dr. Nurhanis Hayati binti Hairum and TS Mr. Zarizi bin Awang. So to briefly explain my thesis report, zinc oxide or ZnO nanoparticle has attracted many scientists and researchers to investigate its potential. Studies of ZnO nanoparticle as photocatalyst in degradation of dry wastewater has been made by many researchers. However, the performance of ZnO fluid as photocatalyst has not been discovered, although it has a potential of dispersing ZnO evenly and avoiding sedimentation process from occurring. Therefore, this study focused on the synthesis of ZnO fluid with different dispersion method. This ZnO fluid was then used for photocatalytic degradation process for industrial dry wastewater treatment via membrane photocatalytic reactor. Alright, so moving on to the introduction, dry wastewater is one of the highly contaminated wastewater due to the various types of dyes in different ranges. Therefore, it is important for the effluent to be treated prior being discharged to the environment. Nowadays, nanotechnology has been used in dry wastewater treatment process. Also, many previous research suggested that ZnO has potential in improving wastewater treatment process. Thus, this study aims to treat dry wastewater using MPR and ZnO fluid for better wastewater treatment. From literature review being done, zinc oxide or ZnO is a semiconductor that has a potential as sensor, catalyst, optoelectronic, antimicrobials, and UV shielding materials. In previous research, ZnO was also proven to have better performance as photocatalyst due to its wide band gap in the structure which shows wurtzite structure. This leads to wider surface contact for the precipitation process. In previous study, the performance of ZnO was studied in the form of ZnO particle. It was believed that ZnO fluid can be dispersed more evenly in a medium as well as reducing chances for sedimentation to occur. Thus, this parameter was studied. There are several methods to synthesize ZnO. The most preferable method would be precipitation based on simple preparation step, low cost and eco-friendly method. Now moving on to methodology. The overview of the experimental work are simplified as in figure. The methodology starts with the synthesis of ZnO fluid, followed by dry wastewater treatment via MPR, wastewater quality analysis, and membrane folding mechanism. If water quality of treated dry wastewater does not comply to EQA 1974, then dry wastewater must be treated again until it complies. For synthesis of ZnO fluid, preparation of deep eutectic solvent or DES solution was done by mixing 12.96 gram of choline chloride and 12 gram of urea as for the ratio of 1:2 at constant heat at 80 degrees Celsius until clearless liquid was achieved. Then, 2.19 gram of zinc acetate dehydrate was added to 30 ml of DES solution. Two batches of mixture was created. The first batch was stirred for 24 hours using orbital shaker at 250 rpm, whereas the second batch was sonicated for 30 minutes using ultrasonic sonicator to maximize the production of ZnO. To be used in MPR system, 0.5 ml of ZnO fluid was added into 99.5 ml of distilled water to obtain 0.5 weight% of ZnO fluid. Next, ZnO fluid was used to treat dry wastewater using photocatalytic degradation process via membrane photocatalytic reactor or MPR. MPR is a hybrid system that combines two degradation processes, which are photocatalytic and membrane filtration. In this system, polypiperizing amide nanofiltration was used. To start the treatment process, 1 liter of dye wastewater and 100 ml of ZnO fluid was added into MPR tank and stirred for 30 minutes at 250 rpm to homogenize. Then, UV lamp was turned on for 20 minutes to start photolysis process. Then, pump was turned on and pressure was set at 6 bar. The permeate sample was flow for 15 minutes and the permeate sample was collected every 5 minutes for 3 hours. The data obtained was recorded into a table form. A total of 4 different runs were done, which are dye wastewater without ZnO fluid, with ZnO fluid ultrasonic, with ZnO fluid stirred, and with ZnO clay. Next, the treated dye wastewater was checked for its quality in terms of pH, color intensity, BOD, biochemical oxygen demand, COD, chemical oxygen demand, and turbidity. For each parameter, water quality test was done as follows. pH indicator paper for pH value. There are 6000 UVV spectrophotometer for color intensity and COD. BOD test for BOD and turbidity meter for turbidity. Then, the performance of ZnO fluid was evaluated by studying the flux decline and membrane falling mechanism. For flux decline, the performance was observed by plotting graph of normalized flux against operating time, whereas membrane falling mechanism was studied based on blocking filtration law using MATLAB software. This was done by using the data obtained from the treatment process in MPR system. Now, we are moving on to result and discussion. For synthesis of ZnO fluid, based on the finding, synthesis of ZnO fluid with 2 dispersion method was successfully done. The result shows the sonication of ZnO fluid produces semi-clear yellow fluid and suspended solid was hardly seen in the fluid. On the other hand, stirred ZnO fluid shows the expected result of white cloudy fluid. This result may caused by the presence of heat generated by sonication process which cannot be controlled. The performance of membrane filtration was observed through the graph of normalized flux against operating time. Based on the graph, it can be seen that ZnO clay gives the best result of flux decline, followed by ZnO fluid stirred and ZnO fluid ultrasonic. This was believed that high impurity of ZnO fluid may reduce the performance of ZnO as photocatalyst, although the improvement of treated wastewater quality can be seen. The water quality analysis was summarized in the form of table which explain pH, percentage removal of color intensity, BOD, COD, and turbidity. From the finding, it can be seen that the addition of ZnO fluid as photocatalyst does improve wastewater treatment compared to photolysis process. Although pH value remain the same, the degradation process happened to be as expected, thus comply to Environmental Quality Act EQA 1974 Act 127. This indicates discharging this effluent to the nature will not cause any harm to the ecosystem. For membrane falling mechanism, the data obtained from MPR was successfully elucidated using MATLAB software and the result was displayed in the table. Based on the finding, cake formation mechanism was found for both stage 1 and stage 2. This may due to the debris inside dry wastewater trapped by membrane surface upon filtration process in MPR. Nevertheless, it has proven that MPR system was fitted for degradation of dry wastewater. As to conclude this research, zinc ZnO fluid was successfully synthesized with the help of deep eutectic solvent solution. The findings of this study have shown the effectiveness of ZnO fluid as photocatalyst in MPR for dye wastewater treatment. Compared to ZnO fluid, ZnO clay proven to have better performance in treating dye wastewater due to high impurity of ZnO fluid used. It was proven that dye wastewater that was treated with ZnO as photocatalyst in MPR give better quality and also comply to EQA 1974 Act 127, which able to discharge to the nature. Also, this process can also be labeled as an eco-friendly method. The membrane falling mechanism was also successfully elucidated using MATLAB software, and cake formation mechanism was observed at both stage 1 and 2. This has proven that MPR system was fit to treat dye wastewater. That is all from me. Thank you.